So this is our Unit 8 test, the one you took right before spring break. Again, we're going to go through this problem by problem today so we can see what you guys missed, what you got tripped up on, and if you have questions, you can ask. So for my first couple of problems here, the directions say find the vertex and the y-intercept for these functions. For number one, what form is this function in right now? This is in vertex form, right? What does the vertex form show me? The vertex, right? So I know the vertex of this from this form that I have right here. What is our vertex? 2, -6. Good. Okay. That's why when we started with our review practice problems, I gave you problems like this. I said, here's a function. What form is it in? What do you know about it from that form? Okay. That's why we did problems like this. So when I see a function and I'm asking you key features, you can decide, well, this is vertex form. So that means I already know the vertex. Correct. The other option would be I'm listing x-intercepts. If you're listing x-intercepts, do not put parentheses around them. Okay. Now, I also want the y-intercept for this graph. What function form would give me the y-intercept? Standard form. I want standard form so that I can see the y-intercept. So good news, this is also something that we practiced. We did a whole bunch of questions where I gave you a function in some form, okay? And then we swapped it out to a different form. So here's one where we had vertex form and we changed it to standard form by distributing. So that's what we're going to do here. I'm going to keep this guy and distribute. So x minus 2 squared means x minus 2 times x minus 2. Make sure you distribute completely. So this would be x squared minus 2x minus 2x plus 4 minus 6. And then for standard form, make sure you combine your like terms. So we would have x squared minus 4x minus 2. There's our standard form. What's the y-intercept? -2. Questions for me on number one? Okay. Number two, I'm looking for the same key features. What form am I starting with for number two? This is standard. What do I know from standard form? The y-intercept, what is it? There we go. Now to find the vertex, I have to change it to vertex form. I don't have to do that completing the square process. So if we look at an example where we had standard form and we change it to vertex, it's where I split the middle. Okay. So I'm going to take 10x and split it in half. That would give me 5x and 5x. So x squared plus 5x plus 5x plus something plus 28 minus something. And then I fill in the blank with my cut in half number squared. So 5 squared would be 25. Whatever I put here as well. And then the x squared through that first blank is what gives me the x part of vertex. And it's always going to be that cut in half number that goes in here. So since it's +5, it would be x plus 5. For the y part of the vertex, we're going to combine those like terms at the end. So 28 minus 25 gives us 3. Here's our vertex form. What's our vertex? -5, 3. Questions for me on number 2? For number 3, we're looking for the x-intercepts and the y-intercept for these functions. This function for number 3 is in what form right now? Go ahead. Standard, yep. I heard the S. Standard form. So standard form tells me the y-intercept. What is the y-intercept? -21. I also want the x-intercepts. What function form do I need for the x-intercept? Intercept or factored form? Yeah, so I need to factor this thing. Since I don't have any number hanging out in front of the x-squared term, that means I'm just looking for factors of c that add to b. The other day, I had a few people say that they preferred that sort of x setup that Delta Math gave you. If you prefer the list that I normally did, that's fine too. Either way, I'm looking for two numbers that multiply to give me negative 21, but add to give me negative 4. Negative 7 and positive 3. So my factor form here would be x minus 7 times x plus 3. So what are my x-intercepts? Make one adjustment for me. What did we say? 7 and negative 3. There we go. Questions on number 3. Okay, so number 4 is in what form? Factored or intercept form? What kind of information do I get from that form? The x-intercepts, what are they? Negative 3 and 4. Perfect. What form do I need to get the y-intercept? Standard. So we're going to distribute this. I'm going to multiply these guys together first. So that would be x squared minus 4x plus 3x minus 12. And then we'll multiply all of this by 2. So that would give me 2x squared minus 8x plus 6x minus 24. Don't forget to combine your like terms for standard form. So we get 2x squared minus 2x minus 24. So there's standard form. What's my y-intercept? Negative 24. Perfect. Any questions for me on number 4? Okay. Number 5 and 6 down at the bottom. We're given a function in standard form, and we want to change it to its other form. Again, we did this, okay? We did like 6 problems like this on Friday, okay? So I had a function, we changed it to its other forms, and we did it with all different types of starting forms, okay? We started with standard, we had a couple where we started with intercept, we had a couple where we started with vertex. We've done this every which way we possibly could, okay? You guys know how to do this. So I've got standard form right now. It asks me for vertex form and intercept form. Doesn't matter which of these you find first. I'm just going to go in order. Okay. So to find vertex form, I need to split the middle. Okay? That's what we did up here for number 2. So 8x cut in half, that would be 4x. 8 cut in half is 4. So x squared plus 4x plus 4x plus something plus 15 minus something. What goes in the blank? 16. It's that cut in half number squared, 4 squared. And now this part here gives me the x part of vertex form. So it's going to be that cut in half number again. So x plus 4 squared. And then we combine like terms at the end. 15 minus 16 would be negative 1. So what's our vertex for this thing? Negative 4, comma, negative 1. Perfect. And now intercept form. I need to factor to get intercept form. So I need 2 numbers that multiply to give me 15, but add to give me 8. 5 and 3. So my intercept form, or my factored form, we also called it, would be x plus 5 times x plus 3. What are our x-intercepts? Negative 5 and negative 3. Perfect. Questions for me on 5 or 6? So this whole first page We were identifying key features from a function, and then we were switching between forms. That's most of what we worked on last week. That's what we did all Thursday and Friday. So from a function, we identified what form it was in and its key features, and then we swapped between function forms. We did a lot of practice on that. You guys know how to do this, okay? This first page is all stuff you guys can do. You can identify key features and you can swap between those function forms, okay? We know how to do this. On the next page, we looked at graphs. So for 7, 8, and 9, we have the graph of a quadratic function, and we want to write all 3 function forms that describe this graph. This is what we worked on Monday. Okay, so we had several problems where I gave you a graph, and then we wrote all 3 versions of that function that could describe that graph. So that's what we're looking at here. So we're going to start with vertex form. If I'm going to write vertex form, I want to identify the vertex. So that'd be this guy down here. That point is -1, -9. So I'm going to take that vertex point and throw it into vertex form. So I know I've got x with something squared, and I should have some number here at the end. If the x coordinate for my vertex is -1, that means I had to have x plus 1 here. Then if the y coordinate for my vertex is -9, that means I had to have -9 at the end. The last thing I want to check is the shape of my graph, because that will tell me about my lead coefficient here. So what I expect is that from my vertex to the next nice points, I should go up 1 and out 1. The next nice points be the points at the corners, okay? Points at the next sort of corner on my grid. So from my vertex up to the next nice point, that's up 1 and out 1. So that means my lead coefficient is the same as my parent graph. My lead coefficient would be 1. When your lead coefficient is 1, you can write it or not. That's up to you. Because when I multiply by that 1, that's not going to change my problem. Questions on vertex form for this graph? Okay. Now intercept form. Remember, intercept form tells me my x-intercepts. So I'm going to identify those x-intercepts. So I have an x-intercept at -4 and another one at +2. So I'm going to use that information to fill in intercept form. I want the same lead coefficient that I had for vertex form. In this case, it's 1. So I'm going to opt not to write it here. If I have -4 as an x-intercept, that means I had to have x plus 4 as a factor. And then if I have +2 as an x-intercept, that means I had to have x minus 2 as a factor. Questions for me on intercept form for this graph? Okay. And then my last one here is standard form. I know that standard form tells me the y-intercept, and my y-intercept here is -8. The bummer about standard form is that the y-intercept isn't all of standard form, right? It's that constant term at the end, but I don't know the x² term, and I don't know the x part. So what we're going to have to do is the same thing that we did on Monday. So I'm going to distribute, you could distribute vertex form or factor / intercept form if you want. I'm going to, just like we did on Monday, distribute intercept form to get my entire standard form. So x plus 4 times x minus 2. That would give me x². Again, be careful with your distribution. Minus 2x plus 4x minus 8. And then don't forget, to get standard form, you need to combine your like terms. So I've got x² plus 2x minus 8. So there's my standard form. x² plus 2x minus 8. And it's always a good idea to check your y-intercept from your function with your y-intercept on your graph. If they don't match, double check your work. Questions on 7, 8, or 9? The other graph problems we had were matching. So for 10, 11, and 12, you were given a function, and then you were given 4 different graphs, and I asked you to match these. Okay. Most people did okay on the matching part. Where we struggled on the graph problems were 7, 8, and 9. But most people, even if you struggled on the rest of the test, did pretty okay with 10, 11, and 12. So what I'm going to do here is start by identifying the vertex in each of my functions that I'm given. So for 10, 11, and 12, I'm going to jot down the vertex. My vertex for number 10 would be 4, 1. My vertex for 11 would be -1, 3. And my vertex for 12, this kind of doesn't look like vertex form where the other two definitely did. But remember, if I don't see what that x coordinate was supposed to be, that means that it's 0. So my vertex for 12 would be 0, 4. Now I'm going to identify the vertex on all of my graphs so that I can see if there are any that match. For A, my vertex is at 4, 1. For B, my vertex is at -1, -3. For C, it's at 4, 1. And for D, it's at 0, 4. Do I have any definite matches here? Where it's only one option, it's got to be this graph based on the vertex. Hannah, you were nodding yes. What's your definite match here? Ten would be graph A. Is this the only graph that has a vertex at 4, 1? It's not. I've got actually 2 options. So since I've got 2 options here, we need to dig a little deeper. So let's look at that lead coefficient for 10. My lead coefficient is 1/2. So that means we're going to open up, since it's 1/2 is positive, but we're going to be compressed. We're going to be a little flattened out. If I look at graph A, we're opening down here. So my lead coefficient for graph A would be negative. That means A actually can't be 10. My other option is C. And if I look to get to my next nice point, it's up 1 and out 1 would put me here, but that's not a point on my graph. My point on my graph is actually lower down because it's been flattened, it's been compressed. So 10 is going to match graph C. Does that make sense? Okay. Now let's take a look at 12. Vertex at 0, 4. We use C. Any of these have a vertex at 0, 4? D, and it's the only one. So D has to be equation 12. And then 11 is not graph A. Those aren't even close. There's actually a typo in the problem for number 11. This is supposed to be minus, and this then should have been -1, -3. When you took the test, if you told me B was the match there, I gave you credit because B should have been the match there if there weren't a typo. If you told me none of these match, I gave you credit for that as well because you're correct with that typo, none of these match. Okay. The other thing I do want to point out about 11 is I have that lead coefficient of 2 there. So if I had to do some more sort of digging on this one, let's say there was another vertex that matched, I would take a look again at that lead coefficient. So this is saying up 2, out 1, and that's what I see on this graph. To get from the vertex to the next nice points, the next points that land at corners, I would have to go up 2 and out 1. And if I look at D, negative lead coefficient there means we should open down, and that's exactly what we do. Down 1, out 1. Questions 10, 11, or 12? Okay, again, this was the portion on the test that most of us were okay. The last section, the last page of your test was the factoring portion. Because we were under a little bit of time pressure, I let you just choose 4 problems from this page. Most people picked 13 and 14 and at least attempted them. And then for the rest, it was sort of a mixed bag of what you tried, okay, or what problems you picked. So we're going to go through all of them. 13 and 14 were probably the easiest problems on here because our lead coefficient is just 1. I don't see anything in front of the x squared number. So this is like when we were changing to intercept form before, right? If I want to factor these, I'm looking for what multiplies to give me c, for this guy, negative 18, but adds to give me a, or b, sorry. What multiplies to c, but adds to b. So it's going to multiply to negative 18, but add to negative 7. What do I? Yeah, negative 9 and positive 2. So my factored form here would be x minus 9 times x plus 2. $14, same idea. What multiplies to give me 20, but adds to give me negative 12? Negative 10 and negative 2. Remember, you can also make a list if you get stuck. So 1 times what, 2 times what, 3 times what, 3 actually isn't a factor of 20, 4 times what, so on and so on. Okay. Negative 10 and negative 2 will work here. So x minus 10 times x minus 2. Now 15, 16, and 17 all give us a number in front of x squared. That means I need to approach these problems a little bit differently. It's not going to be just factors of c that add to b, okay? Anytime I have a number in front of my x squared term, I have a lead coefficient that's not 1, the first thing I want you to check is it a GCF? Could I evenly divide it out of every other number I see in this problem? So for number 15, my lead coefficient is 2, my a value is 2. Could I take 17 and 21 and evenly divide them by 2? No. So 2 is not a GCF for this problem. That means that we're going to have to do that sort of guess and check factoring. Okay. So I would make your factor list for these. So factors of 21 would be 1 times 21 or 3 times 7. I'm going to need one of these factor pairs to finish off my factors here. So anybody have a guess or somewhere they want to start? Pick something for us to try. I need to pick one of these factor pairs and finish off my factors. 3 and 7, sure. So we'll try this way. We'll see if it works. If it doesn't, we'll try something else. Okay, remember doing this before spring break? So if I distribute 2x squared plus 14x plus 3x plus 21, if I distribute, I'm looking to see, do I get 17x in the middle? So 14x plus 3x would be 17x. We got it on the first try. Awesome. My morning sections, we had to try more than one arrangement. That's okay. Distribute. If it works, great. If it doesn't, try again. Okay? So our arrangement here, I'll put that down, was 2x plus 3 times x plus 7. And remember, we want to check with distribution. So that gave us 2x squared plus 14x plus 3x plus 21. And those middle terms added to the 17x that we wanted. I don't care how many options you have to try. If you get a bunch of them wrong, and this is the last thing you try, that's fine. Just make sure that this is the answer that you give me. Okay? So it's okay to guess and check and be wrong and try something again. That's okay. Questions for me on 15? Okay, let's try 16. So again, I want to look to see, is this 5 a GCF? Is it a common factor here? Can I factor it out? So can I divide -1 or -18 by 5 with no remainder? No. So that means, again, we're going to have 5x with something times x with something. And for negative 18, again, I'm going to make that little factor list. So I have my list of things I could use to finish these factors, and we'll see what we can try. So for negative 18, I would have to have a negative number times a positive number. I don't know which one I'm going to want yet. I'm going to list both options, negative 1 times 18 or 1 times negative 18. I could have also had negative 2 times 9 or 2 times negative 9, negative 3 times 6 or 3 times negative 6. 4 and 5 are not factors of 18. And then I've already got 6, so that means I would start repeating my list. So what do you want to try? Negative 2 and 9. So minus 2 plus 9. We'll give it a shot. When I distribute, I would get 5x squared plus 45x minus 2x minus 18. In the middle, I would have 43x. That's not what I want. This arrangement didn't work. So I'm going to swap these. I'm going to do 5x plus 9 times x minus 2. And I'll see what I get in the middle. So 5x squared minus 10x plus 9x minus 18. In the middle with this arrangement, I would get negative 1x. And that's what I wanted. So I tried something, it didn't work. I tried something else, okay? Again, it's okay when you take your retake if you have to try a couple things. That's fine. So we wanted 5x plus 9 times x minus 2. That gave us that middle that we want. Questions on 16? Okay, let's try 17 now. Again, I've got a number in front of x squared, so same idea. I want to see, could I pull this out as a GCF? Could I evenly divide all the other numbers by this coefficient? Yeah, so 22 and 60, I could divide those by 2. So that's what I'm going to do. I'm going to start by factoring that out. That would leave me with x squared plus 11x plus 30. I saw a lot of people on the test have a good idea of where to start on this problem, but then we had some different obstacles that we encountered along the way. So first, if I'm saying divide every term by 2, factor out a 2, that means I expect to divide every term by 2, not just the first one, but all of them, okay? And then I need to write all the pieces that are left over. And then once I've done this, we're not done yet, okay? So this stuff in parentheses, x squared plus 11x plus 30, this is still something that I can factor. This is a problem like 13 or 14, where I want factors of c that add to b. So I want numbers that would multiply to give me 30, but add to give me 11. What do I want? Multiply to positive 6 and positive 5. Good. So this part inside parentheses here, I could factor to be x plus 6 times x plus 5. And then don't forget that GCF that's pulled out. Don't forget that 2 and 5. Questions on 17? Yep, this is my final factored form. And then 18 is a difference of squares problem. So this is one of those missing middle problems. So 4x squared plus 0x, since I don't see that middle term, minus 25. And this is where we said we're going to ignore that 4 for just a second and ask ourselves what would multiply to give us negative 25, but add to give us 0. Negative 5 and positive 5. So again, the 4 didn't go away. We're just ignoring it for right now. But my factors are going to start something x minus 5 and something x plus 5, right, based on these numbers. And now something's got to go in front of x. Some factors of 4 need to go in front of x. But I want the same number to go in each of these spots so that when I distribute, this number is going to be multiplied by 5 here, and then multiplied by 5 here, I want these numbers to be the same so that when I multiply, I still have the same number. The way I'm going to get those numbers to be the same is if the factors I pick for 4 are the same number. So what times itself would give me 4? Another way to ask that would be, what's the square root of 4? 2. So 2x minus 5 times 2x plus 5. Questions for me on number 18? No, on the retake, it will be, the question was, for you guys on Zoom, the question was, I only had you choose 4 on the original. Do you need to do all of them on the retake? No, it's going to be the same direction, same format. It'll be 4 on the factoring. Okay, so that is your Unit 8 test.